We're just talking to Mike.
Is it the only person in there right now?
We're live. Good
Cool.
afternoon. So,
Hello.
yeah, I'd like to welcome everybody to our discussion and demo of the local NeuronSphere. We're going to do a pipeline demo that goes from one end to the other. We've got some code open sourced so you can download the demos, work through them yourself after looking at this video. We're going to refer to docs.neuronsphere.io. There's getting started information there. If you want to pip install NeuronSphere right now, so you've got the local version, get started with that download and follow along if you want. So got Alex Burgoon, one of our lead engineers on the platform. He's going to be driving while we talk about this. I want to talk a little bit about what are we going to show you. So we're going to run the local NeuronSphere. We're going to install, already got it installed. We're going to stand it up from scratch. So we're going to configure a new HMD home. We're going to talk about what that's for. We're going to show you what's inside after you start a local NeuronSphere. So there's a whole collection of services that'll get started locally. And then we'll switch over and look at some tools we're going to use. We'll download some demo projects. We'll talk through the demo pipeline. We're going to go all the way from some generated JSON event data, kind of mixed messages in some files. We're going to go from that all the way through to some dashboards. So hang on, and we're going to switch over to Alex and talk about what's the first thing you should do after you install local NeuronSphere.
After installing the local NeuronSphere, the first thing you should do is run the command hmd configure. And this will set up a brand new, we call it HMD home. It's a directory that contains everything needed to run the local NeuronSphere. You can kind of think of it like a virtual environment in Python if you're familiar with that. It'll hold your configuration. It'll hold a number of different folders for the different services running in the NeuronSphere that get mounted into the Docker containers for their configuration and data persistence. The good news is you can run HMD configure, and even if you don't have the folder already existing, it will create a new one for you. So I'm going to go ahead and do that. Run configure. It's going to give me a default of my home directory in HMD, but we're going to rename it demo ns. And this is setting the HMD home environment variable, because if you can see, it could not find one already set. This next prompt is for HMD repo home. By default, it'll put it in a projects folder in HMD home. Now, HMD repo home is the location where you should put all your NeuronSphere projects. That also gets mounted into a number of services running the NeuronSphere so that they can interact with those NeuronSphere projects or repositories. So we'll accept the default for that. This will be a GitHub org or username, and we'll just use the HMD Labs org. I'll enter my name, my email, and these are used for templating out repos. We'll add like author and email for certain places where that information isn't needed. The next two prompts are Docker prompts, which I'm actually just going to accept as blank because those are only needed to pull down private Docker images, which we're not going to need to do in this demo. The next one is a org code prefix. So our CLIs can create a number of NeuronSphere project repositories, and we can prefix them with an org code. In this case, I'm going to use HMD to follow HMD's naming standard. And then this one is a number of our projects, or all of our projects, are set up to use pre-commit Git hooks. And this will configure my environment to have my email and username or name that I gave earlier be configured in Git, as well as set up a template directory so that all new projects will have these Git hooks created in them, and then we can run on commit, code formatters for Python and TypeScript. I'm actually going to say no to this because I already have it set up, and it did some stuff. It's gonna remind me that I actually need to export the terminal the variable in the session that it's actually set. So we'll do that. I can show that it's now set, right? And we will cd into HMB home and have a look at what's in there. So now the folder is there. A number of, well, right now just 2 folders, a hidden config folder, which we'll look into there real quick. And that's going to contain the important file, the HMD env. HMD env has all of the environment variables that we just set with those prompts using HMD configure, and all of the NeuronSphere CLI tools will need HMD home set, and then we'll read their configuration from that HMD env file. I can actually do configure list env. Now we can see everything got set. That got set. Some of these they didn't prompt us for, and we just set them by default because those are just best practices of what we should say you do, but we do give you the option to override them. The other folder in there was the HMD repo home, the projects, which right now doesn't have anything in it. So we can, I'm going to clear this out. We can now start up their local NeuronSphere, and we'll see a bunch more files come up. We'll do HMD NeuronSphere up. It made a bunch of folders, and now it's starting a bunch of Docker containers. And I'm going to switch over to this. It's easier to view it. And we have a lot more folders in there than before. First up is our data folder. This is going to house the raw data that we're going to be ingested. I already have it pre-generated. I'll copy it over here in a second. It also has a folder for Trino, and this is where Trino can create its own tables and store its Parquet files when you're writing the Trino tables. If we go back, we have a DynamoDB folder that's empty, but that's used to store the running DynamoDB image in the local NeuronSphere, all of its config and persist its data. Hadoop and Hive, same thing. We have config directories that allow you to, configure Hadoop or Hive. Although they're set up right now to be best practices and work with the NeuronSphere, that'll all work. Language packs is where you can store any additional NeuronSphere language packs that you need to use. Postgres SQL is the same as the DynamoDB. It houses a few startup scripts and also the volume mount to persist data, so that when you tear the NeuronSphere down, the data is not lost in the Postgres database. SuperSet home does a similar thing. It's just SuperSet configuration. So we run a Apache SuperSet. Transform will hold a folder for Airflow where they can do logs, and later we'll see generated DAGs in this folder, but we'll get to that when we actually create the demo transforms. And Trino has the config you can override, as well as a warehouse for the Hadoop and Trino and the everything to store data. Let's go see if everything's running now. Looks like everything started. We'll do a Docker PS, and we can see a number of Airflow images got started up. And we can actually go to our browser, and we can see we have an instance of Jupyter Lab that got started on localhost 8888. Yes. And in here, it mounts our HMD repo home that we set earlier. It will mount it into the Jupyter user's home directory under work. So I can actually go in here and there's nothing there, but when we clone down the repos, we'll see some projects there. We have a running Trino cluster, and we can view the cluster overview page. We'll see as we run the transforms, we'll see the queries pop up here. And local SuperSet is also running. Logged in. It's in the process of loading a bunch of the default examples, but we can use our CLI tools to load our own dashboards and charts in here. And finally, Airflow. We reload this, and we'll log in. And so there's nothing loaded in the Airflow right now except a number of default sort of DAGs. and the transform service will use Airflow, and Airflow will run these DAGs to create new DAGs for the transforms that we're going to configure and run here in a little bit. So,
Perfect.
Perfect.
So I'm going to switch over and we're going to talk for a minute about the example projects. I should have been erasing this quickly while he was wrapping that up. So if you're following along and you started your local NeuronSphere, actually I'm going to switch over here. Alex, would you pop up that docs page real quick and show us where there's a page that's got some links that shows here's links to all those local services that should get started.
Yes. Installation. Installing local NeuronSphere. So this walks through, pip NeuronSphere HMB configure, which we did. And then here are the
there you go
strings.
All right. And I'm all erased and we're going to draw a bit of a picture. So we're going to talk briefly about the example projects that we're going to do. We're going to, at a high level, we want to start with a collection of events in some JSON files, and we want to expose them into some tables somehow. And then we might want to look at them in some charts. This probably sounds like every data engineering project that you've gotten, and maybe the requirements were just that plain too. So we're going to get a little bit more specific. What kind of JSON files, what kind of tables, what kind of charts, and do we have some we can just start with? So what kind of JSON? Let's step further back here to the left. We're going to talk, we won't dig into data contracts. We will talk a little bit about IDLs. So we've got this IDL, this interface definition language, and what's most important is that we're going to use that to define some types. This is really common, whether it's protobuf or JSON schemas or some other internal schema structure that you use. You've got some type system over here. We're going to start with a fictitious IDL and show you how to use a notebook to turn that into some standard NeuronSphere structures that we call tabular structures. So we're going to take the IDL and that describes the JSON, and we're going to produce some tabular structures. And then from those tabular structures, we're going to run some code generation, and we're going to generate a whole collection of tables. So we're going to generate some external tables that mount that JSON directly. And then we're going to create some internal tables that are partitioned, that are parquet. And then we're going to generate some code that transfers from there to there. And then we're going to generate some views. And these are really straightforward, right? We're not going to do anything fancy in here. And then we're going to have our charts. We've got some charts stored as code. And we're going to use the command line to deploy those charts into that local superset. And we're going to have a couple of charts over here pointing at our views. So we'll have an end-to-end pipeline. Additionally, in the demo, so Alex is going to cheat here a minute and copy over a chunk of generated test data. But in the example project that we're going to start with on the far left around the IDLs is also a notebook that'll generate a bunch of test data. So Alex will show that to you. We're just not going to make you wait for it. But you can download that, generate your own unique pile of JSON, and then run this through. So along the way, we're going to use a few tools. We're going to meet HMD Mickey. So HMD Mickey is the standard code generator. We'll use that code generator with our tabular structures. This gives us a lot of reuse, right? Bringing things up to tabular structure. We then write a lot of templates that are based on that. So we'll use Mickey to go from tabular structure through these layers. We're also going to meet HMD Bartleby. Bartleby is a documentation generating tool. So our code generator is not just going to generate SQL. It's going to generate some SQL that's embedded in some YAML. And then it's also going to generate some documentation to go along with it. Then we're going to meet HMD Transform. So we've got a local Airflow instance. We'll talk later in a different demo about how to use that directly for Airflow DAGs. In this demo, we're using the transform abstraction. And specifically, we're going to use the Trino provider. And so we are going to generate these transforms in the NeuronSphere transform spec. And then that'll go through a DAG generator, and it'll generate a whole bunch of DAGs. And so we'll go look at how that runs. So we use Airflow for execution, and that way you can take advantage of its scalability, you can take advantage of all its operators, but we don't natively for transforms use it to do full DAGs. We follow a more micro DAG pattern. And again, we'll have a whole other demo where we talk about that. Finally, we're going to look at HMD Bender. So Bender is a tool that we use to run integration tests. You should be able to author and run integration tests locally. So I can build this whole pipeline locally. I ought to be able to run some tests against it locally, and then deploy that into the future and run those integration tests somewhere else. So we're going to write some tests that execute some transforms. So we're going to generate all these structures, and then we're going to run some of these data loads and look at how we could use that to do more testing locally to verify data. And I think that gets us all the way through the end to end. So conceptually, really simple picture. Remember, we're going to start with just the IDL and a little notebook that says we know how to turn it into tabular structures. We're going to start with that little bit, and then we're going to generate and deploy and take a look at the rest of this. So Alex, you ready?
I'm ready.
All right. So we'll start with opening up demo notebooks IDL.
Oh, okay. Well, I was showing that I already copied over the generated data.
Yeah, we should talk a little bit about what this test data looks like, right?
Yeah.
So there's a hierarchy of test data. So we've got some partitions. This data is designed to simulate industrial robot data. So you've got a combination of different JSON objects being streamed into these files. So we have telemetry objects and event objects streamed into these files. And we're generating these into a hierarchy. So making the assumption that somebody's lumping these into object storage for us. And we're going to start, we're going to run the ingestion chain from that hierarchical set of raw JSONs all the way through. So you saw some of the data there. And we've got, a decent chunk. It's enough to get a good demo. So now we can go over to that demo IDL. I guess we ought to clone those projects, right?
Yes.
If you go, yeah, go ahead.
Yeah, so I've exported H&B repo home just to make cloning a little easier. And actually, I should actually properly set it. Thank you. And then we'll go back to the docs here, and there's a local NeuronSphere examples, and we give you a sort of example git clone command to go clone the IDO project. If I can copy just that, go back here and we'll paste it, and it'll clone in. And then if we go look back at Jupyter now, we refresh this, you can see it, it's got the notebook project. We have our IDL YAML. If it'll open, this describes the structure of those JSON files or objects in those files. And if we go back, we have a notebook, and this is the notebook tag generate the data, but we're more interested in the IDL, the tabular structure notebook. I'm going to go ahead and go through, do some imports, set up some variables, load the IDL, set up some functions, and then we'll quickly run that. And, like I said earlier, the H&B repo home folder is mounted into the Jupyter Docker container as this. So it wrote it out. If we look there, we can look in tabular structures, and we can see an event and a telemetry. So we have a list of columns, the name of the table, the version of the IDL, the columns that are in it, the detailed code, message, so on. And we'll use this later in the other projects to generate the transform configs and some documentation. So I'll go back. I'm going to clone those down real quick, those other projects down real quick. Okay, don't overwrite anything. Oh, wait. You know what I'm going to do? I'm just going to go grab the clone command. we're just going to go into repo home. It'll be faster this way. We'll just go to our public GitHub and download the next two, clone the next two from there. So we'll grab this. And yes, I do. Thank you. We'll go back. We'll grab this one. We'll load that one in. Okay, so now we can go back to our Jupyter server. Oh, it keeps up. And we'll go back, and now we have two more demo projects here, and we'll look at schema. So we can go into source, and there's only entities, which is a default folder for our project repositories. Right now it's empty, but when we run Mickey, there'll be a transformed folder here with all the transform minutes. So right now they're not there. Do you want to look at the Mickey config first? Is that what we're going to do?
Let's take a quick look at that. So remember, Mickey is a code generator. And so we ran from the IDLs and we generated our tabular structures. So now we've got some tabular structure files that are, describing rows and columns. And now we've got a bit of a config. So you can see this is in the standard metadata, or in the standard manifest file for the project. This is going to grab those and grab a standard package of shared transforms and merge that together and do the code generation. So this is grabbing from two remote locations. Is that right?
Correct. Yeah. It's going to grab the data from the demos notebooks IDL. So what we just regenerated actually, but it's going to pull it from the GitHub repo, and then that's going to be the data context, and then it's going to render a number of templates from another repository in our public GitHub, and it's going to use the data to render those templates into the transform configs and docs.
Perfect. So let's see what that makes.
Just run HMB Mickey build. And we're going to downloading the stuff, and we're rendering a template. So now if we go back to here, see now there's a transforms folder, and we go in and we can look at these transforms. I'm going to close some of these tabs real quick. We can, see that this one that I got created. This is a simple provider transform using the Trino operator that just creates a schema that if it doesn't exist. And you can see here, this is also templated. So this can be reused with different run parameters. So right now we're going to make the schema name demo, and then it'll be demo source, but you can run it with a different schema name if you so choose. We can look at all these are creating the schemas. It's the same. This one actually creates it with a location given. And then we also create the table for the staging and finals and the final views. So this SQL is generated from those tabular structures, and you can see it's got all of the columns that we had listed in the tabular structures, as well as the partition columns that we're going to add in based on the files, the folder format.
Nice. So this is now we've generated a set of transforms, and this is in the schemas project.
Correct.
So this project is all about, here's all the different structures and schemas that we want to generate related to this set of objects. So there is this abstraction where you could say, listen, I've got those same two tabular structures, but I'm going to go create a completely different project somewhere else and use different templates and generate something, very, very different. So there's a big reuse of the metadata there, in addition to, now we've got these transforms. How do we do something useful with those? Oh, I guess we should look at some docs.
Well,
do you want to look at docs?
We can. Too? I was going to say, yeah. Yeah, we can run HMD Bartleby, and it'll render both HTML and PDF docs. We'll run that. First, it's going to make the HTML. Execute code 0. That's good. Now it's making the PDF doc. And actually, we can go back to Jupyter and look in the docs. And so we got index. This is all the RST that got generated along with the YAML file, the transform files. But if we go to target, Bartleby, you now see a PDF in here, and we can view it. I'm going to zoom in a little bit. It's probably so it's got for each thing, it's got the different sequels that it ran. Yeah.
And we can merge this in with manually generated documentation, and it all ends up in this nice table.
Correct. If we go, now we can go back, and I'm going to clear my console from all the logs, and we can run the transform CLI. So we do HMD transform, load local, and this will load, and we give it the project name of demo config transform device schema, and this is going to make an API call to the running local transform service and say, hey, go look in this project and take all of those YAML files and create the necessary metadata in the transform service, as well as call Airflow and make the necessary DAGs in Airflow. So we'll run that, do some thinking, and then here it'll print out in a little bit there. So you see it loaded all of these different transforms. Now, if we go look at the Airflow, if I refresh this, you can see the DAG make ran 10 times, and now we'll give it a little bit, and we'll see these DAGs pop up in this as well. But while that's doing that, I'm going to go ahead and just do the exact same steps for the other demo project. We'll go in here, config, and load. So the schema project was all the DDL and creating the schemas and the tables, the create table statements and everything. This one will actually create the external tables and then move them through the staging and final tables until finally they're in the final view. So we'll do the exact same step. HMD Mickey build. So I'm going to show you the Mickey config for this in a second when this is done. Well, actually, we can go now. Because if you look, this one is similar in that it also pulls the data from the same GitHub repository, pulls templates from the same repository, but the difference is it's loading a different set of package templates in that repository. So we've used the same tabular structure data and created 2 different sets of transforms for them.
Nice.
And I don't know, we'll go back out because now we can look at the transforms here. We'll close up. So now we got these. So like creating the source table for the event data, you can see, same sort of columns. Got an external location. This is all generated from that same set of tabular structures. Source to staging.
All right, so this is that whole pipeline.
This does the whole pipeline. So it'll create source tables for event and telemetry, load them, move them to a staging table, and then finally move them from the staging table to a final table, which then has a view build on top of it. And it's in that final table that will filter out. So one will only be event data and the other one will only be telemetry data.
Got it.
If we go back here, we can run Bobby on this one. Oh. And we go back, we go to the target, Bartleby, and look at this PDF. You can see it's similar structure, just the different SQL, and different run parameters. Let's zoom that in.
Got it.
We'll go ahead and run the. Ooh, whoa. Go ahead and run. We're going to run the load local command again, only with this project. So those get loaded in. And I'll hand it back over to you while the DAGs are being generated and stuff, unless you wanted to see something else. Because let's see where we're at on DAG generation.
So I was gonna say, let's go look at the test and look at how we can go execute some schemas. Because I think we've got a blank Trino instance.
We do.
We're gonna go run a bunch of schemas now.
So actually, I can show the blank because in this one we have a notebook that will.
So which project is this in?
This is the load project. So demo config transform device load. And this uses it's built into the Jupyter server image we're using. It's a library that we use that allows us to write SQL directly in the Jupyter notebook, as well as connect to the local Trino, or if we have a on-demand cluster in a cloud NeuronSphere, it'll connect that. Right now, we're just going to use it for local Trino. So we're using the local Trino, and we'll show the schemas. So nothing's there except default and information schema. So let's go look at the test, and we'll run those. There I am. We look at this robot test. It's going to run a custom keyword of run transform. I'll show what that actually does in a second. And it's going to give it the name of the transform and then the run parameters to use for that transform.
So this is using the, for the sake of demo, this is just using the testing tool to run through these transforms and create all these objects. We're not actually using it to do any tests. We're not confirming that things get created. We're going to trust it this time, right?
Yeah, we're not actually making an assertion that the data, did anything. It's just that the transforms ran.
Got it.
I can actually show the command to run them real quick. And I'm going to go back real quick because it's going to think, but it doesn't take that long. The custom keyword I use is actually just doing that exact same command, right? It's going to run a sub process of H&B transform, run transform, but this time give it the option of transform name and the run parameters as a JSON string. And it's still, let's go check while we're doing that, make sure everything else got loaded properly. Yep, there are other ones, so we're all ready to go. And we're going to get a list here in a second. Is there something you wanted to see else, Brian, before I do this? Otherwise, we'll just go and run the test.
Well, let's go run the test for the schemas.
Okay, that works. I can just go to this.
And then we'll run some of it.
I'll zoom that in. Yeah, so if we go to... And we can just run HMD vendor, and it'll run a container and install a couple dependencies in the container, and then go through and run those integration tests. So there it's going to go install our transform CLI and a couple other libraries we use to call the transform CLI. And now it's install it all. Now it's gonna run the actual test. We'll be running the transforms. So we'll see a couple kick off, and then we'll go check Airflow and see them running. So that one printed out the log and pass. So let's go back and we'll refresh this. We go look. So those ran a couple times. Is auto refresh on? See, now this one's running. Now it's done. So, you know.
So our test case is now driving through and kicking these different transforms off.
Yes, one by one. So, and if we go here, if you run it with the command without the options, you can select a transform to run. And actually, once you select one, it'll go and fetch the default parameters, and you can either accept that or change them. I'm going to cancel out of this because we already have them running. But go back here, we can see these should be running more. Yeah, see, and there's more coming. And now if we go to the Jupyter and we try, it looks like all the schemas ran. So if we do this, now we can see, you know, we have demo source, staging, final, and UX schemas. Let's see if any source tables got created yet. Nothing yet. I don't know if those have run. Oh, no, of course they haven't. We're going to change that to staging. We'll go down to the staging tables. Now you can see we got an event and telemetry table and staging. Later we'll show, I've actually run this notebook before, and those are old outputs. Show the same thing. Finals going. And I don't have views, but sorry, that's kind of fast. But
oh, so now we've got a bunch of schemas and tables and stuff ready to go.
Yep.
Right. So all of our code generated transforms ran to get the structure all in place. Let's go look at that load stuff a little bit.
Sure. So we use the same keyword, and we have a different set of tests that do the same thing, though. We're going to run the transform to create the source event table with a set of parameters, and I have 6 different parameters set up here for each transform to run. So it'll load 6 different folders of JSON files, and I'll run through and do that.
Got it.
So we'll do a bunch of data. So it's it's going to run them in order. Let's see if that, okay, that finished. They all passed. So now we'll go up. We'll go to the other one.
So now we got done with the schema project. We ran Mickey, we built it, we looked at the documentation, then we used the test framework to drive all the transforms. So now all our structures are created. And now we're back over in the actual loading project. And we've already done our code generation. We deployed our transforms. We looked at our documentation. Now we're going to use our testing tool to drive, running a bunch of test data in and running it through end to end, right?
Correct.
All right.
Do the same thing. Install the dependencies and the Docker container again. So that one did the first row. You can see with this external location. Now it's going to do the next one. We can go back and look at Airflow. See, one's queued, 2 have run already.
So let's look at one of those real quick. Well, just so we can see, so we went from like a couple of utility DAGs all of a sudden to, a whole bunch of DAGs with weird names. And this is kind of what's behind the provider transform. So the provider transforms are generating these microDAGs. So it's a one task DAG, and you can go all the way in here and look and see everything that got templated all the way down. You know, if you're familiar with Airflow, like this is, you know, it'll feel very familiar, with the exception of the fact that there's a lot of, you know, lots of instances of single task DAGs. And you know, from routine operation, we abstract and hide most of this. So the transform CLI and the integration tests that you're seeing, you don't have to go look at the logs. It just shows up. But you can go look at, you know, there's the rendered template, so you can see exactly, you know, what you're used to seeing.
I don't know if this is helpful, but let's see what else has run so far. Yep, so now it's onto the telemetry tables. So actually, we can go here. We can go back up. There's the staging. So if we look at tables and source now, see, it made a bunch of source tables. We got 6, you know, source tables, 1 for each folder that we loaded in. 3 telemetry now. And I think I can actually view the data in here. So we got the data. You can see it's still a mixture of event and telemetry. We'll filter those out later. We can look at a telemetry table if you want. You see, you know, same thing, except it's got a position, rotation, different set of data. Well, different set of columns, I mean. Let's see where we're at. Okay, so those have all run. All the source tables are created. And now we're running taking the source to the staging, and that's done. So now we can go view this, and we can still see similar data, just in a staging table now, rather than the source table, the external table.
All right. And we are eventually going to look at some dashboards, but I think we talked about dashboards as code. Do we have those demos downloaded?
I have them. I can copy them over real quick to the. That will be faster than, because those have actually yet to be released to the public. Those are coming soon, very soon. Projects. And we'll go look at them in here.
So this is a pair of demo projects. One of them is talk through. Show me what we got.
Yeah. Here. So this one is demo for the Explorer portal or SuperSet for the device, and this is the database connections and data sets. So if we go in the Explorer thing, we see, you know, 2 folders, data sets and databases. So this is an exported YAML file from the SuperSet of the database connection. And this SQL Alchemy URL, the tool, you can provide an override. And so depending on where you're deploying it, whether locally or in a cloud environment, you can overwrite that URL. I'll show an example of that. And also the data sets, you know, we have an event data set that uses that database connection, the Trino database connection. Look at the defaults. You can see we're exporting and importing data sets and databases, and also this is where I provide an override so we can point to the local Trino instance. So we have a tool for that called HMD Explorer. I think I gotta go to this one. And we'll do HMD Explorer deploy. We'll use a config file, and we will point to that config default file. You can see it logged into the local SuperSet, got a little token to use, and then imported databases and data sets. And if we go to SuperSet, it's going to make me log in, of course. Started. So we have all the examples, but we don't see any of ours. We go to databases now. We can see the Trino database I can see the connection URL. So that's actually different than what was stored in the YAML file, because depending on which environment you're going to, you can test the connection. Connection looks good. We can also view the data sets. We should see an event data set, which is going to be used by the charts here in a little bit. So I'm actually going to go to dashboards, and we just have the example dashboards. Oh, sorry, I kind of moving it fast, but we'll go back out. We'll go to the dashboards project, and let's view the contents of that real quick. So this is the exact same setup of kind of projects. Explorer assets is at this time we have dashboards and charts. So we have a dashboard YAML that describe which charts are in it and their kind of the layout, the charts which use that data set and how to like display it. So we have a bar chart of event codes and just the raw events table.
And we exported this. We actually used our tool and exported this out of another SuperSet instance, right? Like we built charts in SuperSet. We built the data sets and everything, and then exported them into these demo projects. Okay, just making sure.
Yes, should have mentioned. And then we'll do the exact same command. Bring charts and dashboards. If I refresh this. There it is, demo events dashboard. We can go, and we've apparently got to the part where there's data now. So
nice. So here's our charts that we pulled out of source control and deployed with our CLI.
Yes.
Very nice. All right, that was a pretty whirlwind demo. I'm impressed with how fast we got through it. I think we met all of our objectives going from one end to the other. Can you think of anything that we missed?
I didn't actually show Trino, but you can see all the Trino queries coming in if you wanted to view them.
Yep.
So now it's going through and dropping the source table since we don't need them anymore.
Right. Nice. Well, thank you very much for driving through this today.
Welcome.
If you're interested in using the local NeuronSphere, again, pip install NeuronSphere. It's available. Go to docs.neuronsphere.io. All these available, everything except the dashboards right at the end. As Alex said, we'll get those out with that tooling in the next couple of days. But the rest of this demo is all freely available. Need Python 3.10. And I think Docker
at least Docker 20.
At least Docker 20. And you're good to go. So thank you very much and have a good day.
Thank you.